Hey everybody, we're back with part 2 of my newly constructed lab bench power supply. I call it multi-purpose because it has an isolation transformer that puts out an output of about 129 volts. The mains are 120, and so we're completely oscillated with a floating ground. Actually, you'll see that this ground is floating. There's reasons to float it, there's reasons not to float it. I encourage you to watch some videos on that for safety's sake. And for my use, I have chosen to float that ground. Okay, so what I have plugged into this isolation transformer, just kind of for demonstration purposes, this little fan, and we're just going to demonstrate how accurate actually this meter is here. Now this meter is reading 0.04 amps, and that 0.404 is the power that's required for the electronics to operate this LED meter. So we have to subtract 0.04 from anything we measure. So let's just give a little demonstration. This is a 35 watt little cooling fan, and let's see if it does indicate 35 watts. So we got it plugged in here. Okay, oh, that's nice and cool, a hot day. So we're reading 0.14. Remember, we have to subtract 0.04 amps because of the current that this is using. So it's really 0.10 amps. If we multiply 0.1 times 128 volts, we get 12.8 watts. That's pretty close to what the back of the label on this says, 13 watts. So that's pretty nice. I also can show you what the maximum current draw that it's rated for. It may be an operating limitation. It's pretty close to an amp, but let's see what we get here. I designed this so that we wouldn't go much over an amp, which would be about 120 watts, somewhere around there. So what I've done is I plugged in my little Weller. It has two positions, so let's see what the first position is. Okay, we have 0.90 amps, and as it heats up, it goes down at 120 volts. Second position on, almost an amp, so we got almost about 120 watts. Okay, so let's move on and let's try the DC output right here. I've got a little command set radio hooked up, and I have the filament hooked up to it. So it requires filament voltage and B+ voltage. So we've got, what, 6, 12 volts, 18 and 25 roughly. So we got on about 12, 13 volts here, filament voltage, which is correct for this radio. So let's go ahead and apply some high voltage power to it. We're going to throw the switch. What's it say? 176 volts. Let's see if we can go ahead and power this up. Okay, do you notice the radio's powered up and we're down to 160 with the load at 0.027 amps. That's going to be about close to 4 watts of power. So there you go. That's the intended purpose, is to power up this radio, or an All-American 5 radio. So you got your filament and your B+ voltage. Now this is no longer connected. With this switch to the left, this is out of circuit. It's feeding the secondary of the isolation transformer. That 129 volts is now being rectified and filtered. And we're coming out here with that filtered DC. So, you know, you have to choose a good RC network, capacitor, resistor value. I experimented a little bit, and with using this kind of current, we can come up here and look at the scope. It's showing about 50 millivolts of ripple. So not bad. That's acceptable for what I want to use it for. So with that, I think we'll say end this video, and if you have any questions or comments, please put it below, and please do subscribe. I appreciate that, and thank you very much. Bye for now.